almost pulled off 96 inches a minute and 16,000 RPM. You can see the tool loaded up again, which I put down to coolant failure. I see why people love flood coolant. The tool's heating up, and I'm doing really aggressive 3,000ths chip loads in that ellipse, the one that loaded up just now. Let's go over the operations. The first thing, I did fix the origin. Let's show you that up on the CAD on SolidWorks CAM. This was the mistake I made before, where I had the coordinate system relative to the stock here. I had part 0 out in the corner. I used my little tool probe to find it. Thank you, Avid. And then here, this one was up against the part, and there was a 10,000th or 100,000th. There was 1/10 of an inch step between the two sides. Now I've got it pretty good. You can just barely hang a fingernail. My machinist buddy told me 5,000ths. When I measure it with my trusty Mitutoyo, it came out to be about a 4,000 step. Not sure I'm a good enough inspector to know what I'm doing for that small of a step. What else? The tool stop, we used a couple magnets and slid this thing back. Not the best tool stop, and got some other concerns about the whole setup. But I think with better coolant, the Trico, I finally got the part for the Trico so I can get both halves working. I wonder if I had them both spitting. I got an O-ring for it, but that's the wrong part. Obviously, they just threw a O-ring. Yeah, that's about the right size. So now I can't get the reservoir on, and a lot of Trico misery. But we'll get that sussed. And then I'm curious with 2, if that will provide enough coolant and enough lubricant. The coolant's air, but it's the lubricant. The Trico fluid is really the lubricant that's supposed to keep these tools from loading up. So before you blame Trico, I'm still got a kind of eBay, crazy setup. It's not legit. So let's go over the ops real quick. We can show you pictures as we go. Okay, up here, the 2 setups. Flange to the right. See, the ellipses were closer to me. The vise is sideways in the thing. The ellipses were closer to me. The holes were further. I did the flange pointing right first, then the flange pointing left, second setup. Flange leftward, flange rightward. So in the first setup, cut the back edge. Feeds and speeds, pretty reasonable. 12,000, 48 inches a minute, okay? Then here's that picture. It did it in 2 whacks, so we should show that, I guess. Here, you can see it went about halfway, then back. The hole, same thing. I kept it at 12,000 RPM, get some horsepower out of it up at that speed. 48 inches a minute, 2,000ths of a chip loading. So it did okay. Surface finish is fine. Problem is, I measured it, and it's 3,000ths of an inch undersize. And when I started with the first part I did, much slower speeds, much slower feeds, 8,000, well, more than 8,000. I think it was about 10,000. It was right on. It was within 5/10,000ths, which is a testament to that Avid Benchtop Pro, right? So that's a concern. But otherwise, the surface finish, the hole looks fine. It didn't load up the tool. Then the ellipse, much tougher operation. Here's the ellipse. Same thing, 12,000, 2/10ths of a chip load. Here's a picture of the surface finish. Not too bad. Looks okay. Then this front edge, 2 whacks, two passes to cut it halfway. You can see the line of demarcation. So this one, I went to a heavier chip load. I said, let's try 3,000ths, which is 72 inches a minute. That's hauling through aluminum, but in 2 whacks, so nothing too aggressive as far as material removal rates, but pretty darn fast. Here's a picture of that surface finish. Came out okay. I'm pleased with it. Let me orient myself. Yeah, not too bad. Not too bad. But when I measured the part overall, it's supposed to be 5.000 inches. It's 13 thousandths oversized. Huge error. Don't blame the mill yet. You know, we'll look into it. And there's a clue we'll show you in the next setup. I think it's just, I've got such a wimpy vise, and it's on it's inside a plastic tub. It's not hard mounted, aluminum to aluminum, and there's probably some compliance going on there. I think stuff is just moving around, and I can prove it to you when we talk about this next setup. So let's go to the flange leftward setup, where it's sitting in the vise, you know, like this. Flange rightward close, flange leftward open, cut stock. Because there's that big chunk, relatively big chunk hanging off, I figured deck that off, cut that off, let it fall and affect the end mill the way it does. Here's the speeds and feeds. I did it in one shot. Let's go fast. I did it at 16,000 RPM and 64 inches a minute, two thousandths of an inch chip load. The picture you're seeing, that's the piece that fell off. So remember, this is conventional milling on this side. It's Klein milling one side and conventional milling the other side of this slot that it's cutting. And you can see, just like happens with conventional milling, there's little chunks stuck on and all of that. And you can see the little arc where it separated. But overall, you know, it came off. I guess that's the only thing to worry about. And now here's the backside edge. This is the cleanup pass I did. I think 20 thousandths I removed. 16,000, 64 inches a minute, 2 thousandths chip load. Let me go look at that, and came out pretty nice. Right? Nothing, no divots. It's really flying. A high-speed spindle, that's the whole point of this stuff. So the picture, it looks pretty good. I'm happy with it. Really hauling. Apparently the Trico coolant could keep up with it. Next is a hole, and it started having trouble. You might not be able to see it in the video. I'll show the videos in a bit. Re-show it. Maybe I'll try slowing it down too. Here, the hole, I bumped it up. See how he's getting greedy. I wanted to see where things started going south, and they started going here. I think the tool started to load up here. It's getting hotter and hotter, right? So it's working and working. And yeah, the Trico's blowing air on it to cool it off, but it's not like flood coolant where you got a liquid to metal removal, heat removal. So same 16,000, but a bigger chip load. Now it did this hole at 96 inches a minute. Same kind of problem. Here's the picture. Surface finish is fantastic. You know, I love it. But took the Mitutoyo to it, 5 thousandths of an inch undersize, 0.745. Once again, when I did this, the very first part, you know, with everything slow and being real careful and conservative, it was within, one of them measured perfect, one of them measured a tenth, 5 tenths off. So 5 thousandths is a big error, and I think I'm just moving stuff. I think I got, this cheap little vise and all that. I think I got compliance. Time to buy better vices and do something different with this mounting a plastic tub. It ain't working, not if it's causing this much error. Of course, we're also learning maybe this machine isn't meant to go this fast. So that's that. Let's go next to the ellipse. The ellipse, I think I even humped it harder. And this is, of course, where it really failed. Yeah, 3 thousandths. Or no, that's where 16,000, 96 inches a minute, 3,000 chip load. It's loading up. Can't get enough coolant. I'm hoping with the double nozzle Trico, with 2 sprays of lubricant, I would like to try this again. So there's that picture, surface finishes, where it before it gummed up here and left a big chunk. I guess I can break that off. The surface finish is pretty good. It's got a little divot on this side for stuff. Then the other mistake I made, you can almost tell, I left stock allowance on this one. I did a roughing operation and forgot to remove the stock allowance. So this one's 20 thousandths undersize. So I figured, why simulate it? It's so simple. If I'd have simulated it, I'd have seen that extra stock around this ellipse. Then the front edge, here I went crazy fast. Oops. Let me get you going here. I think I went to 4. Yeah. like a Destiny tool brags about. Go 4,000 chip load, which is 128 inches a minute. Now, surprisingly, let's 16,000 RPM. Let's look at the picture. So let me get oriented here. It's this one, right? Yeah. It's really nice. You know, you can see the little divots as it's roaring through this material. But this side measured even worse. This side, instead of 5.000, it's 5.02, 20 thousandths. It's huge error. At first I thought, oh, the mill's junk. No, the mill's fine. You can see here, look at the corner here where, okay, it's roaring through and then it just gets to the corner and all these side loads that I'm climb milling into get relieved. And you can see it put a little divot. Matter of fact, there's a little divot at the front and a little divot at the side. That's because I'm hammering into this so hard that it's flexing the vise, flexing everything, and maybe the gantry, right? Maybe we got stiffness. We're shaking out stiffness issues of the whole machine here, but it wasn't this bad. And when I measure from this divot over to this side, then it's only 8 thousandths over. So accuracy, you know, I got on a speed kick because, hey, I'm an American guy who likes speed. So now I'm going to be more worried about accuracy and doing roughs and finishes. We're going to play with that for a while. Meanwhile, I got visual mill installed, and we'll go over that next episode. So I think that's all we got to talk about. Let's go look at the videos. I'll put the speeds and feeds on top of it. You can judge for yourself. Take a look. Okay, so we're back. Let's see, I can always clip this out, I guess. Let's try the hole in the ellipse where it's really taking some chips. Let's try it in slow motion. You can slow down Vegas. So let's see if we can do it in slow-mo. All right, that's third chips we got from this machine. I hope you're having as much fun as I am. It's a blast actually making stuff. Now my mind's racing on all the projects I can finish and the things I can do. Got to learn more CAM. My buddy said that SolidWorks, his Hawkridge, those people I like, Hawkridge in Silicon Valley, they offered him a deal, upgrade SolidWorks CAM to a perpetual license for $1,000, good for 2 days. So I don't know that that's the same as getting SolidWorks Professional. He didn't make that clear because I saw Hawkridge had that for $2,400, and with maintenance, I suspect it'll be the $3,000 I got quoted from a reseller out here. So that's going on. We're going to play with more CAM, make more chips. Stay tuned. Hope you're having fun. We'll see you next time.